All right, hello everyone. My name is Anton. I'm a third-year PhD student from Lund University in Sweden. And today I'd like to show you CodeProber. This is joint work with my supervisors, Görel and Niklas. And CodeProber is an exploration tool for compilers. I'll spend most of my time today with a live demo, but I'll first begin with a small introduction into what the problem is we're trying to solve and where it fits in the world of programming. And the problem we're trying to solve is programming is hard. I think everyone in this room is trying to solve it in one way or another. People are creating programs, and because it's hard, they might make mistakes. So one common mitigation to this is we write compilers or static analysis tools that look at your code and point out when something went wrong. You might misuse a type, you might miss binding a name before you use it or something like that. Now these are great, but where did they come from? They're also just programs, and someone else created them. And they might also have made mistakes. And that's where CodeProber comes in. It's an exploration tool for the tools that look at your code. It's one step removed from normal programs. It means my target audience is quite narrow. It's people who create compilers and analyzers. But I think that narrowness allows us to do something quite interesting. That's all the background. Whoops. Oh, this is super zoomed in. I'll zoom out a little bit. So this is CodeProber. It's a client-server-based application. The client is written in TypeScript, runs in the browser. The server is written in Java, currently runs on my machine, but it could run somewhere else as well. Most of the surface area is a text editor. This is the Monaco text editor. You've seen it in Visual Studio Code, for example. But the thing that makes CodeProber interesting is this little window. This is what we call a property probe, or just a probe, and it's like a magnifying glass that looks into the compiler at one particular operation it's performing. In this case, the compiler has this sort of analysis that checks whether a declaration is final or not. This is one of the simplest forms of analysis a compiler does. The top half of the window is the input to the probe, which tells us we're looking at a variable declarator. The property name is final. And this here is the span where the declaration exists. And when I hover over it, you can see the span in the source code gets highlighted as well. And then the output says it's false. One of the most important things about CodeProber is that everything you see is, well, live. It reacts to changes as soon as they happen. So if I add final, it becomes true. If I remove it, it becomes false again. But this is not a very interesting analysis, so let's upgrade. Oh, I forgot. I mentioned earlier, this is not a compiler by itself. It's not an analysis tool by itself. It's merely a visualization tool. So we're looking at Java because I'm currently exploring a Java compiler. But you could swap that out with another compiler if you want. But so you know, this is not Java unique. So what I now like to do is ask my compiler if it can figure out the compile time constant of this addition expression right here. To do that, I'll right-click, create probe. Now I get a list of all the AST nodes that overlap with the place where I clicked. So I clicked on number 2, so that's on top of the list. That is part of an addition expression, which is part of a declarator, and so on and so on. And when I hover, you see the span gets highlighted. I'll select the addition expression, and now I get a new list containing all the properties that I can inspect. So this is a full Java compiler, so there's quite a lot of functionality here. And I'll use the filter to select what I'm after, constant. And there we go. It works. I can make changes. Again, changes update. When I enter an invalid state, it will crash, because CodeProber does not just handle the happy case. It tries to also show you when you've made mistakes and capture those and show that in the UI. That's pretty cool, but we can go one step higher in the complexity. This is a Java compiler, after all. We can ask it to generate bytecodes. So this is the bytecode representation of this method. And again, as with everything else, if I make changes, it immediately updates. When I first started using this probe, I didn't know anything about the Java bytecode format. But now, I think I know quite a bit, because I've been playing around with it quite a lot. CodeProber is not only for finding issues with programs. It can also be really useful for educational purposes, just to play around and see, how does this work? What if I change the input to this? What is the output? You may have used a tool called Compiler Explorer, godbolt.org. Well, this is a very similar thing, except you can do it not just with code generation, but with all properties in your compiler. And if I were to make some more changes, this is supposed to be nonsense code, just showing that it's updating as I'm typing. Yeah, here you see how branching and more variables are handled in bytecode. All right. Certain kinds of analysis, they rely on the control flow of a function to do their work, and CodeProber can render that as well. To begin with, many people when they see this, they think, well, I wonder what the colors mean. They are randomized, so they don't mean anything. They're just there to make you show where one arrow ends and the next one begins. But again, if I make changes, you'll see it also updates live. So if you do control flow graph-based analysis, that might be something you want. One thing I really like about CodeProber is that I'm actually interacting with the AST here, but I haven't shown you the AST. It's sort of hidden away. Some people want to see the AST, and we can do that too. And so this is the actual data that I have been interacting with all this time. And I can again hover over things. I can click to create probes and so on. There is some things that CodeProber can do for you. So far, I've only shown things that sort of, well, except for the AST view, I've shown things that the underlying tool provides for me. CodeProber does very little. It can do things like searching. If you're not sure of a certain node you're looking for, you just want to find all nodes that fit the criteria. You can do like question mark equal type equals int. This will select all nodes where the type is, well, int. I can extend this filter and say, actually, only give me the things that are constant. Now we only get the literals. If I change the declaration to be final, again, it updates. So yeah, if you're not sure which node you're looking for, you just want to find everything where something is true, you can do it this way. All right, I'll end the demo by doing a small little demonstration of what it's like to use CodeProber as a development assistant while you're working on your compiler, making revisions. Let's say I've worked with my compiler for a while, and I noticed that something is wrong with constant propagation for multiplication expressions. This does not look correct. It should be 246, and I can sense that it is using my input somehow, but not correctly. So I'll skip ahead in time a little bit and say, okay, I figure out what's wrong. I'll go to my editor. Whoa. I'll look up the place where I have defined this constant expression. I'll see mulexpr.constant is the left operand multiplied by the left operand. This is probably not what I was intending to do. So I'll change the left to right and recompile. So now I'm actually rebuilding my compiler. I've shown you a lot of interactions in CodeProber where as soon as I made a change, the probe updated. CodeProber also monitors the file system so that whenever you change your compiler, the probe updates. So if you have multiple monitors, I recommend putting CodeProber on the secondary screen, and it will like open a few probes, put it there, and then it will keep showing you live values as you rebuild your compiler. Okay, that was the demo. So we looked at some very, very simple properties like isFinal. We generated bytecode, looked at the control flow graph, and some other features here. This was all done with ExtendJ, which is a Java compiler. It's written using a metacompilation system called JastAdd, which uses reference attribute grammars. And in one sentence, with RAGs, you place computations on top of AST nodes. And that's what allows this type of interaction that you just saw, because you first select a node, then you select a property, and all the functionality is on the AST nodes. That's what enables CodeProber to work. A colleague of mine is trying to visualize the set of properties that exist to find out if there's cycles of dependencies between them for optimization purposes. So he gave me some screenshots from his tool. Each circle here is a property, a piece of functionality inside the compiler. The lines indicate the dependencies. If I zoom out, these are all of them. There's 2,500 properties in this compiler, give or take. Imagine if you're joining a team working on this compiler and you're told, hey, improve this, work on it, add some feature. It's quite a lot of functionality to get into. Something I like to do in that situation is start to playing with it, give it some input, see what output comes out. And to do that, you need to go through some form of entry point into the program. Perhaps you can run the type checker to generate semantic errors. Perhaps you can start a language server to interact with it that way. Or if it's a compiler, you can, well, generate code. Bytecode in this case could be assembly code as well. With CodeProber, instead of having like 3 or 4 entry points, you have all of them. Everything becomes interactable. I'm very biased, but I think that's pretty cool. Of course, with an asterisk, it only works for tree-like data structures that put computation on the AST nodes. But if you could make something like this that works in a more broad context, I would love to try it. I think this way of playing with programs is really powerful. CodeProber does work with non-JastAdd compilers as well, as a disclaimer. I've talked about JastAdd so far, but the tools to the left, Spotbugs, PMD, and Wala, they work in CodeProber, not written in JastAdd. And it's not just Java. We have ChocoPy, which is a subset of Python, and simply C, a C-like language, that works as well. If you're interested in integrating it with your tool, if you do computation on a tree, please let me know. I'm happy to help. All right, I'll end with some case studies of using CodeProber in courses. So, first course we use CodeProber in is a compiler construction course. Students go from not knowing anything about compilers, and in the first lab they do simple scanning and parsing with a handwritten scanner and parser. And then in the last lab they do code generation. They generate assembly code, link it to a binary, and run it. And every lab sort of builds on the previous one. Somewhere in the middle, they start defining these more advanced properties to perform interesting computation. And we introduce CodeProber to them there. So I gave them a short presentation saying, this is the tool, this is how it works, here's how you create a probe. You can use it if you want. And then at the end of each lab, we ask the students, so did you use it? If so, what did you think? So informal interviews. We've done this 2 years now. The first year, CodeProber was quite new, so it didn't have that many features yet. We got mostly positive feedback. One common point of feedback from students was, I don't have a mental model of the AST. Like, I don't understand how source code maps to the AST, and then there's features on top of the AST. They would like to see the AST. So that's why we added the AST view that you saw in the demo. Roughly a third of the student groups regularly used CodeProber in the labs. This year's instance of the course, it ended 2 weeks ago. No real common point of negative feedback, because mostly people were happy. Some technical issues, but in terms of features, they seemed a lot more positive this year. And we have around 2/3 of students regularly using it. There are other factors as well contributing to this group, but we can see, or it seems like they're happier now. And it doesn't help for today, but we have better course evaluation coming in a few weeks. One course where we do have numbers from students is in the program analysis course. Similar situation, there's a series of labs, but instead of the students writing everything from scratch themselves, the teacher gives them, here's a finished compiler, now you add analysis on top of it. So this is a different kind of challenge. Now they have to get into this code base that's relatively big and understand it, and then add their analysis on top. And I think CodeProber can work pretty well here too, with the sort of exploratory, playing around to see what happens for certain input and output. All students used CodeProber in this course, which sounds really positive, but actually they were forced to, so it doesn't really tell us much. They had to do it to present the labs to the TAs. But in the course evaluation, we had this statement. CodeProber was effective at helping me discover and understand bugs and omissions in my analysis implementation. So this was written in the evaluation, and then they had to answer fully agree, fully disagree, or in between. We only have 15 people who responded to the survey, but there's a clear trend. People seem to be happy with it. Yeah, so I don't have that many more evaluations of CodeProber yet. Unfortunately, it's something we want to do in the future. It seems like people are happy with it in the scope of creating compilers and analysis tools. Something we might do in the future, looking forward, is code review. I don't know if, well, probably most of you have been in a situation where you're reviewing code. In a larger team, you're all you start from the same code base, you make your changes, and then you put up the changes in a pull request or a merge request, and you ask someone, can you look at this, approve it, so that I can get merged back into the main branch? And it's not a very fun experience, I think. Most people are, well, I've never spoken with someone who said, I love code review. Most of them say, it's not very fun, but it's necessary. What if you could just like right-click and on a complicated-looking method and find hey, give me all the related test cases to this method. And then you can look at the log file from running that method, and you can diff in the previous and the new version. Like adding probes, it's already written with the client-server model. We think this, it doesn't look very good on the projector. Well, I think this could be a really nice way to enhance the experience of doing code review. Wow, I'm done 4 minutes in advance. What's wrong? Thank you. So, yeah, I recorded a video of the demo you just saw. It's on YouTube. I'll put the slides up on the live webpage later if you want to get them. We wrote a paper about this, submitted to SLE last year, so you can read more about the underlying technology of how CodeProber works. For example, I didn't show this, but if I move this expression around, it stays, it keeps tracking the node. Even if I make structural changes like wrapping the expression here inside of an if statement, it still is able to track it. Also, it can track nodes that are external files or built into the compiler. Yeah, that was a lot of work. It's more like a third of the paper is just how we track nodes. If you're interested in that, please check it out. And finally, CodeProber is open source. It's BSD licensed. You can do whatever you want with it. Look at the code, play around with it. And if you're interested in integrating your tool with CodeProber, please ask me, and I'll be happy to help. Right, questions?
Cool demo. I really love the floating window. I was thinking about, for code review, just like a comment before I have a question, I would love to see the control flow, because I know that like the first time I'm reading through a larger pull request, the first thing I'm building, I read from top to bottom to try to understand how all the changes relate to the different chunks of like, oh, this calls that and that kind of stuff. So I have to like build that in my mind by reading the thing, and then I can actually do review, which is kind of an annoying step. Yeah. If I could just visualize it, it'd be way easier.
Yeah, we could do a diff of the control flow graph almost and highlight those arrows that are diffing more. Yeah, that would be really cool.
Yeah, it would be really helpful, because then I could read it in control flow order as opposed to alphabetical. Yeah. But I was curious about you mentioned other use cases where this thing could be useful. I was curious if you thought about applying this to documents, because documents also have an AST, like if you're doing Markdown or any of these other things, like if you look at the HAST, H-A-S-T ecosystem, like the entire ecosystem is taking different document formats and converting them to ASTs. And so they have this sort of actually surprisingly formal structure. When you look at a prose document, you might think there's not a lot of structure there, but there is quite a bit that could be explored using kind of the same user interface, it's just a separate set of formalisms. So I don't know if you've thought about applying it that way.
We have not. I'm trying to think of what's an interesting property you would like to look at in that situation. If you could handle it, yeah.
Sorry, a couple of things that came up would be like headings, paragraphs. Like you could basically like expose the entire heading structure of the whole thing. Like show me all my H1s. You could, and then there are other things that are unique to like English language or like language in general. Of like show me imperative statements, show me questions, show me like you can. Yeah, so that would be.
Yeah, so like advanced. Okay, yeah, very very interesting. No, we hadn't thought about it, but I'll think about it after this. Thank you.
Thank you. Very interesting talk and demo. Can you go back to the slide with the visualization of all the different properties? Just trying to understand a little bit better what you mean, or by each property, are you referring to like a different attribute occurring on a different non-terminal, essentially, or like the 2,500?
Yes.
Number.
So I have a bonus slide.
Okay.
So I was going to talk about what I mean with a property in more detail. I thought I didn't have time, but now I was 4 minutes early. So most tools, all tools that I know of, probably not all of them, but you take this source code and you parse it into a tree structure, and then you associate properties with the nodes in the tree. I think to this level, this is how all tools work. They associate intrinsic properties with the nodes. Something like the declaration. We know the ID being declared here. It's X for one of the declarations. We know the literal value of integers. What JastAdd does then is to place also computed properties on the AST nodes. These are the ones in orange. These are slightly more complicated. The parser cannot figure this out. At parse time, you have to do it as pass later or somehow do it later. Something like, what is the compile time constant of this addition expression? Well, that requires you to find out the constant of this variable reference, which requires you to find out which declaration it's referring to, which requires you to, like it's the clauses chain of things that needs to be computed. So when I say property, it's these boxes on the next side of next to the AST nodes. Yeah.
Thank you.
Hey, Will Creighton from Brown. So your diagram at the very beginning showed CodeProber at the very top, but it leaves out the question of who's supposed to help you build CodeProber.
That's you. It's open source. You should help me.
My question is, first, what was most difficult in implementing this tool? And second, are there certain frameworks that you think could be built that would help you either at the front end or the back end to build this tool more easily?
Yes, okay, thank you. What was more difficult? I think it was the node tracking. There's two challenges to tracking nodes. While the user is actively mutating documents and structure completely changes and they might copy and paste several lines at once, you need to do it in a way that's both robust to handling changes and quick. Otherwise, the experience is really bad. In the beginning, you could wait 2 or 3 seconds between typing and getting the result. Still pretty cool, but not as cool as what I showed today, I think. So we worked a lot of how we track accurately and quickly. And there's some benchmarks in the paper showing that if you have a project with 100,000 lines of code and you have 15 windows on screen, then it updates all of them within 40 milliseconds. So we managed to push down to the point where the only thing limiting you in how many probes you can use is the size of your screen, more or less. So yeah, tracking nodes.
And is the work that you did very specific to your domain and your tool, or do you think there's something more fundamental here that could be extracted out that would be useful more broadly in live tools, is kind of what I'm getting at.
Okay, yes. The node, okay, so the title of my PhD position is cloud-based language tooling. How do you build tools that run well in a client-server environment? And this locator data structure for how do you describe computation at a distance? I'm the client, the server is over there, has some form of data structure. How do I describe the tree and the computations happening there? That's what this tracking thing really is. CodeProber is just a realization of, well, okay, we have this algorithm. What do we make of it? Well, let's make a compiler explorer. But I think you can take the tracking data structure and use it for other experiences as well.
Cool, thanks.
Pat's been waiting a long time.
Yeah, I think so too.
Hey, thanks. That was great. This is really interesting. Could you say a bit more about so you had the visualization where you showed bytecode and you hover over the bytecode and you can see the associated source code.
Yes.
Can you just say more maybe about how that, what's needed, what you need to change in the compiler to support that? And because having built visualizations like this, I know that often you end up, having to put a bunch of stuff in the compiler that's specific to the tool, or at least that's what I've ended up doing.
So this is a great question, thank you. This is Godbolt, the compiler explorer I mentioned earlier. It also has the same thing where I can hover over the bytecode here and I can see the corresponding line getting highlighted. So the information needed to do this is already present in most class files. You have the actual bytecode instructions as one, I think it's called attribute in the class file. Another attribute is source something something. It's the mapping from attribute offsets in the attribute array to which source line does this correspond to and which source file. So we just combine the array of instructions and the array of positions. In terms of code, I think it was 15 lines of code I needed to add to make this appear specifically in CodeProber with this highlighting enabled. Then I could just reuse the rest of the code generation code that existed. We try to be as much plug and play as possible, where you can look at properties that you already defined, but you can also then create some more special properties, like the one rendering control flow graph or this highlightable lines of text that enhance the experience. We support both. Yeah, 10, 15 lines of code.
Cool, thanks.
Last question, I think here. I know there's so many. Ask them in the Discord, I'm sure. Well,
yeah. I'll be here until Friday, so.
Thanks for the great talk. I'm wondering if you've undersold the value and potential applications of your work, though, because in that first diagram you said it was for the compiler writers, but I'm wondering how can I use this as a programmer using, writing Java code or whatever, and you hinted at this a bit in code review, but I'm curious, Can you talk more about how do you think people might use this in the flow of doing programming. It's not live programming on the runtime data. It's live programming on the compiler structures, right? And how do you think about, like
Yes.
I think type error red squigglies are an instance of live feedback on compiler structures, and is this a generalization of that idea?
So I didn't show this, but we have squiggly support as well, of course, in the tool. Yeah, code review, I think, is one of the simplest answers to your question. This is something that could benefit most people. The challenge here is the term AST node is not very clear to most programmers, I think. You need to start reading a little bit about compilers and to understand what the tree structure, what the nodes are called. Like, if I tell someone, hey, create a probe on the variable declarator, they might be able to figure out what it is, but it's much easier if you're actually part of building the compiler. So you need to create some prettier presentation layer on top of this to make it more usable for most people. I don't think the actual code review UI will look like this. I think we'll take a few of these probes and put a prettier coat of paint on it and package it more nicely. I think that's what's required to make it more mainstream, let's say. But for now, we made our lives easier by just targeting people working on compilers and analyzers.
Makes sense. Thanks.
Yeah.
Thank you. That was a great question.
Yeah. Thank you.